Alrighty, welcome to the Pewaukee YouTube channel. Today I'm going to do a run through of a Java snake game project I recently finished about, I think 2 weeks ago, somewhere around there. So let's run the program, see how it works. So here we have a welcome to snake game. Press the play button to start. So let's get her going. So first of all, it starts off pretty slow. We can see a high score of 18. I've already played a little bit. Um, And so basically we have the head of the snake, which is Scion. Uh, I believe it's how you say it, or Cyan. Oh, okay, I may have gone off the edge. And then the body of the snake is green. You can just do a quick Google search of the snake game kind of rules. I guess I can give a quick run through as well. You just want to collect as many. Uh, Here I just have circles, but they're usually apples. So when the snake eats the apple, the snake the snake's size increases. So we can play again. And also I have a feature here where the speed increases for every 5 points you score. So let me see if I can do that. Oh, jeez. Okay. Maybe I'll just have to take my word for it. But anyways, let's end that and let's go through a walkthrough. About 640 plus 70 plus, about 100. So it's about 750 lines of code. It probably could have been written cleaner. I mean, for me, I mean, I felt like it took a good amount of time, but or understandable amount of time. So let's get started with the import statements. Okay, so I didn't want to do star imports, um, so I just added some general comments here. And so this is a JavaFX project. So it was made by doing create new Java project from VS Code and JavaFX create from archetype right there. So that is how I created it, and I got the basic kind of outline with primary controller, secondary controller. If you ever set up a JavaFX project, you know what I'm talking about. Otherwise, we can just walk through it for now. That can be a separate video. So we have our package. This is the folder in which it's located. And for the import statements, so here are some import statements for writing to files because we want to save the high score for access later or for access when we play the game. At these import statements here, so this IO exception is required for the application, as we'll see in the, I believe it's the start method. And then here are some other imports. I'm not exactly sure how these two are used. It might be for writing files as well, but I'm not sure. And then input array list and random. So array list is for a list of pivot points where the snake has to turn. And then random is for a random location for the apple to spawn for the head of the snake to collect and eat. So now all these imports are, let's go through these first. So these ones are from top to bottom: keyframe, timeline, application, FX collections, and observable list. So basically the keyframe and timeline is for running a periodic task every certain amount of time. The application, you need to extend the application in order to run a JavaFX application. That may have been a mouthful, but anyways, that's what needs to be done. Um, and then finally, we have collections and we have observable list. Observable list will be helpful later on to access the parts of a snake, which is I used a group object. So we can find which children of a group object to delete. So here we have action event and action handler. These are for buttons and timer, as it says. Uh, fxml loader is for kind of the base project. I really don't need it to switch between screens because I don't have two screens. I could have two screens, but I chose not to. So we have group to make a rectangle outline. or to make a grid, but also the snake. And then we have all these other imports are just kind of JavaFX scene imports for the most part, just to help me draw objects and have buttons and labels and fonts and all those stuff. And the final import here is for running time tasks using animation.timeline, which we saw up here on line 18. So let's get into it. So public app extends application. Um, Very simple starter. Here we have a bunch of variables. They're kind of self-explanatory. You have a scene, pane, start again, play again, or start button, play again, and these labels. And then we have two different groups so that when every time that the snake moves, we want to refresh the snake so we can just delete all the, uh, or how I did it was deleting all the objects of the snake group and kind of re-adding them. Here we have a timeline, we have a snake object, we have a integer list, which will be of length 2 for storing the apple coordinates. And here we have an array list of pivot points for where the snake has to turn. So if the snake was going up at first and it turned this way, we want a pivot point here. So when it goes up, so when all the other body parts of the snake go up, we want them to turn. I don't know if this is used, highest score, because I believe that's extracted from a file. But here, path name, where is this? Highscores.txt. Let's put in the relative path instead. Um, Replace this with double backslashes. Okay. And let's get into the program. So when we start the program, we're going to have the stage argument, or this is the override function start, which works from the launch function, which is called in main. So here down all the way in main, we have the launch function, which eventually comes back to the start function, which ultimately starts the game or starts the program. And so here we have definition of a start label. I don't want to go through all these because there's a lot more interesting stuff to get to. So I did not use a kind of grid layout, which I probably should have, but instead I just kind of translated it and see where things fit, which is probably not the best idea. So hopefully for the next project, I'll take it upon myself to learn. Just, constraint, or not constraints, but just layout properties and different ways to kind of put stuff. And so here we have the start label, then the score label. Uh, let me just pull it up. So we have the start label, which is this. We have the score label, which is down here in red. I don't think my face cam is blocking. Yeah, down here in red. We have the game over label, which will be shown when I crash into the wall. Game over label. We have the high score label, which is here. When the game starts, it shows, or it pops up. We have the start button, which is seen when we start the program. We have the play again button, which you see down here. And then now we define the different groups and the panes. So a pane can have, I believe, infinite groups, as you can see in this kind of node arg0. That kind of is like star args in a way that you can have, I believe, an infinite amount of groups. That makes sense for me anyways. So I create a group, one group, which is the main group, which takes care of the rectangles and I believe the apple as well. And then we have a snake group. So basically it's easy to separate into two groups because then when the snake moves, we can just delete all the snake group objects and then kind of just put them in a different place. So it's easy that way. So this here, basically, um, what does it do? It makes the grid. That's what it is. So the grid is 20 by 20. So here we have a double nested for loop of 20 by 20. And basically we just have these kind of coordinates that get set. and we set the width and the height of the rectangles to 20, and then we call group.getChildren.add, and that puts in the rectangle. And so we do these add statements afterwards so that, for example, this game over gets put on top of the boxes. We don't want it to be behind. Also, another thing to keep in mind is that some of these labels, for example, get over, set visible as false to start off with because the game has not ended yet, for example. Okay, so now the start button, whenever the start button gets hit, we want to start the game. So let's go to that function. Also, when the play again button gets hit, we want to do the same thing. So let's go, oh, let's do this too. So the scene creates a new scene with a pane with the window width being 475 and the height being 500. Add that here. Equals 500. And the background color will be white. So we set the title, set the scene, and set the resizable to false because we don't want to resize the screen. We can see that when I go against it, there's no ability to resize. So now let's go to start game. So these statements here, they just kind of get rid of whatever's not needed. So start button's not needed, so we disable it, set it to be invisible. The game over, uh, the game over should be set to be invisible because once we hit the play again button, we don't want that to show up, right? Start label should be set visible to false. And then the play again button should also be gone. And here we want the score dot set text to be equal to 0. So that's this here in red, this number here. We want that to be put back to 0 once the game is started. So now we want to, once the game starts, we want to get this high score and we want to put it here. So we'll have a high score label. So we can see high score dot set text. It's going to be set to high score colon plus the highest score, which we see right here. So let's go to this file reader, file writer, and reader. Let me do, I don't know exactly where that is, so let's just do something like this. Here it is. Okay. So the purpose of this function is to read the highest score from the file to be used to the high score label. Then find the current score and update if necessary. So we have the buffered reader, which is a new buffered reader from a file reader of the file the file variable, which is defined all the way up here with the new file of path name, which is this here. So now let's go back to, okay, back to the function. And then I'm just going to define a string here, and we're going to read the lines of the buffered reader while it's not equal to null. So while the file still has lines, although there is only one line because the high scores.txt file just stores one number. But we just want to read till it's null, I guess, anyways. But in theory, we could just say, we could just read the line and then set that equal to string if we wanted to. So I could say something like, string equals br.readline. And that would be fine. Instead of having this while loop, I just say something like this. Highest score equals integer.value of star or string. And then we want to close the buffered reader because we have extracted the highest score. So now here, we want to try and see if the high score, I believe, is, what is it? Yes. Okay. So here we're making a new writer of a buffered reader to the new file output stream. So we want to write to a file. So we want to do, basically what we want to write is the highest score. So integer.value of score.text, if score.text, so this value here, is greater than the highest score, which is stored here, then obviously we want this to override this. So if I got a score of 19, we want the score of 19 to be here for the highest score. So then we're going to write that score.txt in the file if it's the higher score. Another problem I ran into was that if I didn't have this here, if this was gone, a problem would be that um, if I didn't get a high score, this would be an empty file. So basically what you have to do is you have to put in the highest score anyways. So if the score.getText is higher than the highest score, fine, put the score.text get text. Otherwise, you need to write the string of the highest score anyways, so that the file is not empty. So you just want to catch any IO exception that happens. And now let's go back to where we were before, which was somewhere around here. Okay, after this, right? Then we want to set the highest score.text equal to the highest score. And the reason I don't use any return statements is because all these are defined as variables in the object initialization, which will be seen, um, or yeah, or just in the object initialization here. All these things are already defined, so when I update the high score somewhere else in a different function, there's no need to return it at all. So let's see, where was I? Ah, yes, I was here. Okay, let's end that. So now I want to create a new snake. Okay, fun. Let's go to that class. So here we have the snake class. So we're going to have an array list, and this array list will be a collection of body parts that the snake has. So we're going to have um, integer of length. We're going to have the head coordinates and the tail coordinates. We're going to have if it's colliding with itself, and we're going to have the array list of body parts. So when we call the constructor of snake, our initial length will be 5, so set that equal to 5. Head and tail coordinates will be new arrays of size 2, and then we will set the coordinates to be about in the middle of the board. So we remember here that this kind of formula, 25 plus 21 times something, was used a while back in making the rectangles. Right here we can see 25 plus 21 and 25 plus 21. So we're going to use that same formula here. I also could have made a kind of like a formula in the location class, which we're going to see soon, which maybe would have made this a little easier. But anyways, the head and tail coordinates are given as shown. And here we're going to declare the body parts. And we're going to add the body parts based on location. So here we have these 5 array list add statements. And these array list add statements add a new location object. What is this location object, do you say? So it has 2 constructors, location with 2 integers, or location with 2 integers and a string direction. So this string direction will be very helpful in kind of seeing what pivots we need to kind of, excuse me, not what pivots, just to see what direction each specific body part has to travel. And then we have some simple getter and setter methods. So the location class is pretty simple. Oh, we're in the snake class. Okay, and then here we have some getter and setter methods here. The only thing that's different is that we have a change body part instead of kind of a set body part. So usually you have these getter and setter methods, and usually the setter changes the whole variable. But in this case, for an array list, I found that it was easiest to say get body parts add body part, and change body part. Thought that that was the simplest. So now let's go back to here. So after we added the snake object, what do we do next? We call snake make. So let's see where that is. Snake make. So this draws the snake to the screen. So that's what we're going to see here. So for each body part, we're going to draw a rectangle. And if I equals 0, that means it's the head, because we're kind of doing just this I loop, right? Simple I loop. And we're going to say if I equals 0, we want the rectangle to be cyan, or cyan, something like that. And we're going to say that otherwise the snake will be green. So that's what we see. We see that the head of the snake is blue and the rest are green. So that's what we want. Perfect. And so now we're going to go back to where we were. Okay, that was simple enough. Wait, no, here we are. Okay, and now we're going to say apple chords equals make new apple. So make new apple is a very simple function. Make new apple is a very simple function. So make new apple returns a integer list, and basically all it does is it uses this random import to find a place where, excuse me, what am I saying? So it uses a place where the snake is not currently. So it makes sure that the, what does it make sure of? Oh yeah, that the apple does not spawn inside the snake. So when looking at the style properties, I could find that there was a fill object. Because we're using rectangles, there was a fill object, and that fill had a hexadecimal representation of the color. So I was able to use that and kind of do a little string splicing here to get a substring and then find out if it matched. So this would be green. This color, I believe, is green. And basically what happens is that, let's see. So we make the new apple. We want to delete each apple from the screen. So I believe this searches for red because we want to delete the red object, the red apple, from the group. So now we delete that here using a observable list to delete. So since group.getChildren returns an observable list, we need to kind of make an observable list to have an object which we can delete from an observable list. So basically all of these black rectangles are part of a group object, and these black rectangles are all in an observable list and they're all nodes. That's a bit confusing to wrap your head around, but that's what we'll say for now. So basically what we want to do is we want to make a new random object. We want to set the collision to false. So basically, so long as the new apple coordinates does not collide with the snake, we want to keep making new apples so long as the apple does not collide with the snake. Yes, that makes sense. So now we want to find the x chord and the y chord using the same formula that we saw earlier, but using a random integer. And we want to make sure that the body parts do not collide with the snake, or the body parts of the snake do not collide with the apple. And so long as that happens, we want to make the apple, add it to the group, and then return the apple coordinates. So that's what happens. We return the apple coordinates, which can be seen, let's see, where was it? Here. The apple coordinates are now a integer list of x coordinate and y coordinate. two objects or two integers. And then we're just going to initialize pivots finally. Um, so let's go to the next part. So here I've taken this from Stack Overflow. I forget exactly who did it, but basically creating a new timeline object and then using that in order to um, uh, move the snake every certain time interval. So this duration dot milliseconds over a time interval. Initially, it starts at 300 milliseconds. So that means that um, excuse me, the snake moves one square every 300 milliseconds, I believe. I think 300 milliseconds is a starting thing. So now uh, we want to handle something every 300 milliseconds. So first of all, we're going to delete the snake. This basically just deletes it from the group. So it's a very simple function, a one-line function. Just takes the snake group, and deletes all the objects. And now we're going to say if check collision or check out of bounds. So out of bounds means that it's gone outside the 20 by 20 grid, and check collision means that it has collided with itself. That means that the end game should be called. So the end game basically just puts this button out there, puts this text here, and you can play again if you'd like. Oops. I think the high score was actually set back to 0. That's no good. Oh well. We can modify that back to 18 if we'd like. So let's do that. Alright. And now, let me just cut that. And so if end game happens, then we want the timeline to stop. And now we want to update the coordinates and size. So this will be the last function that we look at, because generally that's the most painful to update the coordinates. So we're going to update the coordinates and size. Let's look into that. So here we're going to update the coordinates and size. So basically what this does is it moves each body part in its certain direction. So remember when we initialized the snake, right? All the body parts were moving up. All the directions were up. Oops. All the directions were up. So we want each body part to move in that certain way as well. All right, starting back again. Okay, they're supposed to continue here. Let's go back a little bit. All right, so for every pivot, we need, okay. I didn't explain this here. So for every pivot, right? So once we, let's see. Once we hit an arrow key, that's when we add a pivot. Okay, so that's what this is saying right here. All right, so we have this, we have the head coordinates, and we have the change in y and the change in x for each body part, right? And then we want to call the body part by location. So here for pivot and pivot, so you might be asking, how do pivots even form? Or how do we even add pivots in the first place? Because if we say pivots.add, where does that take us? Okay, that takes us here to a handle function. So this is scene set on key pressed. Okay, so this happens whenever any key is pressed. So using JavaFX, we can incorporate event handlers in the same way as an action listener. So a Java Swing action listener. So that's what I'm doing here. And so basically what I want to do is anytime you hit the arrow keys, you want a certain square to be a pivot. So for example, if the snake is going up, so let's play the game. If the snake is going up to start, oh, is it run? It's not gonna run. Okay, I don't know what happened. It just it just crashed or something. Let's let's try that again. Okay, so if the snake is going up, right when I hit the left key, we see this pivot point right here. And so I want that to be the pivot point. So I want the direction of whatever body part to change in the direction of a pivot, right? So basically I have this um, event handler here, and it uses a switch event.get code by the key event, and these codes are up, down, right, left for the arrow keys. So if we look at up, so one of the main things that we want to make sure is that when the snake is traveling up, we don't want the direction to be down, because if we think about it, right, that means that if the snake is going down and then you hit the up key, then it collide into itself. We don't want to do that. So we're going to say make sure that the head direction is not down. This is what this says. And make sure that what does it say? That no pivot exists. Pivot exists. Okay, let's find that. Pivot exists is here. So this basically just searches and makes sure that a pivot does not exist at the head location. Yeah, that makes sense. Make sure that, oh man, make sure that a pivot does not exist at the head location. Yeah, and so in doing that, we can set the head direction. We can set the direction of the head to be equals to up. And then we can add a pivot point. So we add a pivot point based off of location, and we want the location to have an x coordinate, a y coordinate, and a direction, because at a certain pivot, we want to change the direction, right? So that's basically the same for the rest of the cases. So if the snake is going down, then or if we hit the down arrow key, we don't want the snake to be traveling upwards, because then it would collide onto itself, right? So the same thing with right and left. If the snake is going right, then we don't want to hit the left arrow key because then it collides into itself, and vice versa. So now let's go back to, where were we before? Right here. So basically what this is saying is that for every pivot, if a body part of a snake goes onto a pivot point that we've set, we want to make sure that that body part's direction is changed for the next iteration. So let's say the snake is going up and there's certain body parts, right? And then it turns like this. So these body parts are originally going up, but when it gets here, the body part direction needs to change and go this way. So that's basically what this is saying. And so now we have a switch statement based off of body part direction. So if the snake is going up, then we want the y coordinate to change by -21, because remember the coordinate system in Java, and I believe in many other programming languages, is that the coordinate system y equals 0 is at the top of the screen, unlike usually the bottom in a normal Cartesian plane. And then we're going to say the same thing for, or well, down is going to be an addition of 21 in the y direction. And then right and left are the same as a Cartesian plane, right being positive and left being negative. So we don't want this to happen. We hope that each snake body part has a direction, and if it doesn't, then that's like a horrible case, and then we'll just exit the program. But I don't think that happens. Let's get rid of this. All right. So here when the head of the snake is changed, we want to update the head coordinates. So that's what's being done here. Set the head coordinates. And if um, the tail is changed, or when the tail is changed, we want to update the tail coordinates, which is done here. And then otherwise, we can just update the coordinates like normal. So we can say for every body part, set the x equal to what the x already was, plus the change in x, and the same thing for y. And now this one here, snake.change body part. Let's look at that. So snake.change body part. So we want to just modify because so we've set the body part to have a new x and a new y. So we want to change that body part. This statement might not actually be needed simply because it's in a list already of body parts and it should already change, I believe. That makes sense. So I think since it's already each body part is already in a list of body parts, there's no real need to call line 439 here. So I will just comment that out. So let's see if it still works. It should still work, I believe. Okay. So yeah, there's no need to set the body part because it's already being changed. So let's get rid of that. So now if the this checks if the apple has been collected. So if the head coordinate is equal, or if the head coordinates are equal to the apple coordinates, we want to insert new body part. So let's take a look at that. New body part, here it is. So basically what we want to do, this is why we have the tail coordinates in the first place, so that we can, we can put in the new addition of the body right after the tail. And basically the way this works is that whatever direction this tail is traveling in, we want to put this tail, or we want to input the new body part in the opposite direction. So if the snake is traveling up, let's say the tail is around here, we want that new body part to be inserted right about here. So if the snake is traveling up, we want to insert the body part down. So that's basically what this function does here. And then, let's see, what do we do? Add new body part. Oh yeah, add body part is a function in the snake class. It's right here. So we're just adding the body part to the list of body parts. And then we want to set the tail coordinates to the new location that we have made, which is through the switch statement. So we can see let's look at case 1. So case 1 is up. So if the snake is traveling up, then we want to input the new location basically under the tail coordinates. Okay, let's go back to here, right here. So snake.set length, we're going to say snake.get length plus 1. You know, simple thing if the apple is, what am I saying? If the apple has been collected, right, the snake's length is updated. And then apple chords equals make new apple. So basically if the apple is collected, we want to make a new apple, right, for the snake to collect. And finally, update score. Let's look at update score. So basically, I want to update the score anytime that the apple is collected. So this is what this does here. So string text equals score.getText, and then we just add, oh, excuse me, we just are going to add the number by 1, or whatever's in the text field. So whatever is here in this red, we want to increment by 1. And so here we have an interesting type of formula here. So basically, if the score, which is a number, is a multiple of 5, we want to decrease the time interval. So when we decrease the time interval, this, let's see, where is it? Let's take a look and try and find it. Yes, this here, this time interval will decrease. So the time interval decreases. That means that the snake will travel faster because there is less time in between executing this handle function. So we have updated the score, and now what else is left in this function? Oh yes, the deletion of a pivot. Now this is an interesting one. So I wrote this huge comment here, but I'll try to explain it shortly. So basically, if the snake's tail coordinates match the pivot, the first pivot, because we have to remember that pivots are added by the arrow keys that we press. So if we press the left arrow key first, then that pivot point is going to be the first one that is deleted, right? Because the end of the snake will reach that pivot point first, compared to if we said left, if we went left of the snake, this might not be left, but if we went left and then we went up again, then that up pivot would be deleted after we turned horizontally. So that's basically what this says here. If the snake's tail coordinates match the first pivot, we want to, what does it say? Snake.getBodyParts.get, so we want to get the last body part, so the tail body part. We want to set the direction, okay, equals to the first pivot. So it's basically, I had an issue here where the snake would turn, but the tail body part would keep going in the same direction. So this is what it prevents this, or that this line 468 prevents that. Let me show you what I mean. Let's see if I can show it the horrific tragedy. So you can see there that the tail, without line 468, the tail continues upwards, and that's obviously not what we want, right? And then the first pivot can be removed because, okay, the tail's direction has been set. Now let's remove that pivot. So let's see, I believe that almost covers everything because, oh, we can go over endgame. So endgame, we just want to update this file writer and reader will update the score. Update the high score if needed after the game ends. And basically, I believe that is most of it, if not all. I believe I've gone through it all. Um, yes. Let me just do a quick little scroll here. Okay, I believe so. So the main things to kind of take away was, at least for me in this project, was the time interval, right? So using Java animation.timeline in order to in order to basically excuse me, the main problems was trying to use java.timeline, or trying to set a task to happen every certain amount of time. That was one of the main difficulties. And basically, I was a little bit confused on how to make the snake move. I didn't understand. So that was one of the main things I learned, kind of how to use animation and how to kind of delete a group and then re-add the elements in order to make, I don't know, just in order to make a snake game. That's pretty much it. That's all I have for this video. I hope you enjoyed. Just do a quick code run through. That's for fun. There's a lot of code here. Nope, this comment is not properly expanded. Let's do that for fun. See all the glory. That's it. Ending with public static void main.